For today's lesson, we are going to learn more about trigonometric ratios. And more specifically, we're going to learn about a thing called SOHCAHTOA. SOHCAHTOA is an acronym that we use to help us remember all of the ratios for sine, cosine, and tangent. Our learning targets for today are for you to be able to say, I can find the sine, cosine, and tangent ratios for an acute angle of a right triangle. So let's go ahead and review what sine, cosine, and tangent of an acute angle are. So notice that I've said of an acute angle. For right now and where we are at in this unit, we are only going to be taking the sine, cosine, and tangent of acute angles. Now the sine of an acute angle of a right triangle is equal to the length of the opposite side divided by the length of the hypotenuse. Shorthand, we call it OPP divided by HYP. And that is where we get the SOH from SOHCAHTOA. We have the sine of an acute angle of a right triangle. So this is for just of a right triangle, the acute angles. And if you think about a right triangle has two acute angles. So this is just for one of them. It is equal to the length of the opposite side divided by the length of the hypotenuse. There's your SOH. Sine of an acute angle is equal to opposite over hypotenuse, SOH. Next, we have cosine. The cosine of an acute angle of a right triangle, that is equal to the length of the adjacent side divided by the length of the hypotenuse. And this is where we get our shorthand of ADJ divided by HYP, and where the CAH from SOHCAHTOA comes from. So the cosine of an acute angle of a right triangle is equal to the length of the adjacent side, that's the side that touches the angle, divided by the hypotenuse, which is the longest side of a triangle. That's where the CAH comes from. The cosine of an acute angle is equal to the adjacent divided by the hypotenuse. And finally, we have tangent. So the tangent of an acute angle of a right triangle, that is equal to the length of the opposite side divided by the length of the adjacent side. Shorthand, we write OPP divided by ADJ, and that is where the TOA comes from of SOHCAHTOA, the TOA. It is the tangent of an acute angle of a right triangle that's going to be equal to the length of the opposite side divided by the adjacent side. This is where the TOA comes from. SOHCAHTOA. So let's go ahead and review some of these terms again. I know that you've seen this before, but I want to make sure that I actually review it again. So let's go ahead and make angle A our focus angle. So there's always two acute angles of a right triangle, and one angle is going to be our focus angle because that'll be the angle that we're either requested information about or the angle that is given. So we're going to call that angle A in this problem. The side that is across from angle A is known as the opposite side, the opposite leg. And this leg does not touch our focus angle. It does not touch angle A. So that is something I need you guys to know. It does not touch angle A, and we call that the opposite leg. does not touch the angle that we're interested in. The adjacent leg is the leg that does touch angle A, and it also touches the right angle. So that's something I want you guys to write down. This leg or this side touches both angle A and the right angle. So it touches both parts, it touches both angles. So in this case, we have, it's also going to be a leg, so it's not going to, it's different than the hypotenuse. It's going to be its own leg, its own side. That's going to touch angle A as well as the right angle. So it touches both your angle of focus and the right angle. Finally, we have the hypotenuse, and the hypotenuse is always across from the right angle, and it is the longest side. So I'm writing it's the longest side, and it's always across from the right angle. Now you might be saying, Miss Oliveira, I already know all of this. This is something that I've learned a long time ago. I know what a hypotenuse is. When you're in the throes of doing some of these problems, I don't want you to get confused because technically the hypotenuse will always be adjacent. And so I want you guys to always know which one's the adjacent compared to the hypotenuse. And the thing that I majorly want you to know is that the hypotenuse is always across from the right angle versus the adjacent side actually touches the right angle. So those are the main things that I want you guys to know when it comes to the terminology. So looking at we want to now find the sine of A. And the sine of A is a ratio. It is a ratio of the opposite divided by the hypotenuse. And our opposite leg in this case, that is BC. That name is BC. And we're going to divide that by the hypotenuse, and the hypotenuse is AB. So there's BC over AB. And if we knew the length of BC, we would be putting in the number. If we knew the length of AB, we'd be putting in the number. So in this case, because we don't, we're just going to use the letter names, the names of the actual segments. So let's go ahead and find the cosine of angle A. Cosine of angle A is equal to the adjacent side, and the adjacent side is AC, divided by the hypotenuse, which once again, that's AB. The tangent of angle A is equal to the opposite side divided by the adjacent side. So that's going to be BC divided by AC. I had a student in class ask me, Mrs. Oliveira, does it matter if I call it CB or CA? And the answer is, of course, no, because your order does not matter whenever we are naming a segment. The order of the endpoints do not matter. So either way is perfectly fine. All right, let's go ahead and look at example number 2. In example number 2, it says, write each trigonometric ratio as a fraction and as a decimal rounded to the nearest hundredth. Now, in this problem, it's going to be nice because the fractions will already be simplified, but if they weren't simplified, always make sure that they are simplified. So always simplify the fractions if necessary. So always simplify the fractions if necessary. So some problems will require it, other problems will not. This is a nice problem, it will not require it. So in this problem, what we want to do is we want to write each trigonometric ratio as a fraction or a decimal. So we have working with angle A and then working with angle B. So let's start with angle A. Making angle A my focus angle, I know that side 5 or side BC is the opposite because it's right across. I know that 12 has to be the adjacent side because it touches both angle A and the right angle, and 13 is the hypotenuse. And especially for my visual learners, I strongly recommend that you label. Labels are really, really helpful, especially when you're trying to visualize what is going on in a problem. So I'm going to write sine of angle A, that's equal to opposite divided by adjacent, and the opposite is 5, divided by the adjacent, which is 13, and all you're going to do in your calculator is you're going to put in 5 divided by 13. So I have a graphing calculator, but you can use any calculator just to go 5 divided by 13, and when you do that, you end up with 0.38. We're rounding to the nearest hundredths. Cosine of angle A, that's equal to the adjacent divided by the hypotenuse. So that's 12 divided by 13. And 12 divided by 13, that's equal to 0.92. Finally, the tangent of angle A, that's equal to the opposite divided by the adjacent, which is 5 divided by 12. And 5 divided by 12 is 0.4. And if you're rounding it to the nearest hundredth, that's going to be 0.42. So let's go ahead and look at the measure of angle B. Angle B is now going to be our focus angle. So I'm going to use a different color to represent angle B. And now things are going to change. 5 is no longer the opposite side. It's now going to be the adjacent side because it's the side that actually touches angle B and the right angle. 12 is no longer the adjacent side. It's going to be the opposite side because it's the side that's across from angle B. And the hypotenuse will still remain the hypotenuse because of the fact that it's the side that's across from the right angle. So now we're going to go ahead and find the sine of B. So the sine of B is opposite divided by hypotenuse, and that's 12 over 13. And I already found what 12 over 13 is. That's 0.92. So now I'm going to find the cosine of B. The cosine of B is equal to the adjacent divided by the hypotenuse. So that's 5 over 13. And I already know what 5 over 13 is. That's 0.38. Finally, we're going to find the tangent of angle B. So that's going to be opposite divided by adjacent. So that's 12 over 5. And when we put 12 over 5 into our calculator, we end up with 2.4. So there exists a really cool relationship between the sine of one angle and the cosine of another. And that is that they are equivalent to each other. The sine of one angle is equivalent to the cosine of another. So that's something that I really want you guys to keep in mind, that there exists this special relationship. The sine of one angle is equivalent to the cosine of the other acute angle in the triangle, and vice versa. The tangents, they share a special relationship. Tangent of one angle is equal to the reciprocal of the tangent of another angle. So they are going to be reciprocals of each other. And those are the two cool relationships between the sine, cosine, and tangents of the acute angles of a right triangle. So now what we're going to do is we're going to use these ratios to help us to find missing side lengths. So I'm going to write at the very top SOHCAHTOA. And what's really nice about writing SOHCAHTOA at the very top is it helps me to identify what trig function I should use in order to help me find a missing side length. So in this problem, 31 degrees is my focus. Side X touches both 31 degrees and the right angle, making it the adjacent side. 17 is across from 31 degrees, making it the opposite side. So what we want to do is we want to figure out which one of these, sine, cosine, or tangent, we should use to help us find X. Well, it's all based on information that's given, on information that we are asked to find. So with respect to 31 degrees, I know the opposite. I want to find the adjacent. Which one of these uses O and A? That's tangent. That's your TOA, which means that you're going to be working with tangent. So I'm going to write that the tangent of 31 degrees, that's going to be equal to the opposite, which is 17, divided by the adjacent. Now, if we were to put the tangent of 31 into our calculator, the tangent of 31 is simply going to be a decimal, a ratio. that has been simplified. It's going to represent a number. So this is just a number. And what's cool about it is that we can make this number be over 1. By doing that, we can now find the cross product or use cross product to help us to find what x is. So this is x times the tangent of 31 is equal to 1 times 17, which is 17. I'm going to divide both sides by the tangent of 31. And what's going to happen is the tangent of 31 is going to cancel away, leaving me with x equals 17 divided by the tangent of 31. And I'm just going to put this into my calculator exactly as I see it. So 17 divided by the tangent of 31, that is 28.29 if we were to round this to the nearest hundredth. So 28.29 is our answer. Cool. There exists a shortcut that I want you to be aware of whenever a variable is in the denominator. So if you see the variable or x in the denominator, what you can do is you can flip-flop the trig ratio with x. So you can flip-flop the trig ratio with x. So look at what we had at the start. I had the tangent of 31 over 1 equals 17 over x. And by the time we made it to this step, look at what happened. The tangent of 31 and x flip-flop positions. X became over here and tangent of 31 came down below. They flip-flopped. And whenever you see that variable in the denominator, I strongly recommend that you use that trick. It will save you this line of work. It'll save you just a little bit. All right, let's go ahead and look at letter B. For letter B, I know that 52 is right across from the right angle. So that makes it the hypotenuse this time. A lot of times kids will think it's the adjacent because it does touch 42, but you have to be really mindful as to where the right angle symbol is. X is across from 42 degrees, so that makes it the opposite. So looking at our SOHCAHTOA, what uses opposite and hypotenuse? O and H. That's sine. We're using SOH, which tells us that we are going to be working with sine. So I'm going to take the sine of 42 and I'm going to set it equal to the opposite, which in this problem is x, divided by the hypotenuse, which is 52. And now remember that sine of 42 is just a number, and we're going to make that number over 1 and do cross product. X is not in the denominator this time, so there's no special trick for it. So instead, we're just going to go x is equal to 52 times the sine of 42. So I guess if you wanted to call it a trick, if you have a number in the denominator, you're simply going to be multiplying by the sine or multiplying by the trig ratio. So then this is going to be x equals, and we're going to take 52 and multiply it by the sine of 42. So I'm just putting it into my calculator exactly as I see it. And when I do that, I end up with 34.79. Let's go ahead and look at letter C. For problem letter C, this is 39 degrees. And we know that 18 is the adjacent because it touches both the right angle and the 29 degrees. X is across from the right angle, making it the hypotenuse. And what uses A and H, adjacent and hypotenuse? That is cosine, CAH. So that tells me I'm going to be working with the cosine of 29. The cosine of 29 is equal to the adjacent, which is 18, divided by the hypotenuse, which is x in this problem. What's really nice is that the variable of x is in the denominator, so I am allowed to flip-flop the cosine and x, making this x equals 18 divided by the cosine of 29. So I'm going to go ahead and put that into my calculator, 18 divided by the cosine of 29. And I end up getting 20.58. And there's my value for x. All right, please go ahead and try example number 4, letter A, on your own. Please go ahead and pause the video and see if you can handle doing letter A on your own. When you have an answer, please go ahead and restart the video and we'll see how well you did. All right, hopefully you were able to notice that x is the opposite side and 12 is the hypotenuse because it's right across from the right angle. O and H, that tells me I'm working with SOH, which is sine. So we're taking the sine of 38 and setting it equal to the opposite, which is x, divided by the hypotenuse, which is 12. I'm going to make this over 1 using cross product. We end up with x is equal to 12 times the sine of 38. And in this problem, we're being asked to round to the nearest tenth. If you would round it to the nearest hundredth, it's not that big of a deal. It's just as long as your answer is correct. That's all that I'm really looking for. And the sine, 12 times the sine of 38, that's going to be equal to 7.39, or in other words, 7.4. All right, so now what we want to do is we want to figure out another way to find the value of the missing side. So this is a little bit different. What would be something that we could use? So my hint for you is, do you know the measure of the other acute angle? So could we find that? Could we find the measure of the other acute angle? Well, yeah. So we could use the fact that all of the angles add up to 180 degrees. So I can go 180 minus 90 minus 38. And what that's going to give me is the measure of angle Z, our remaining angle. And 180 minus 90 minus 38, that's going to be equal to 52 degrees. So now that I know the measure of angle Z, the next thing I can do is I can instead, if I put in the measure of angle Z, which is 52 degrees, X is no longer going to be the opposite, it would now be the adjacent, and 12 would still remain the hypotenuse. I could work with cosine. I can use the cosine of 52 is equal to the adjacent, which is x, divided by the hypotenuse, which is 12. Using cross product, this is 12 times the cosine of 52 is equal to x. And if I do this correctly, 12 times the cosine of 52, I end up with the same exact number that I ended up with up here, 7.4. Why is that? Why is this true? Well, if you think back, remember what I said before? That the sine of one angle is equivalent to the cosine of another? That's exactly what's happening right here. The sine of one angle is equivalent to the cosine of the other angle. So that is something I want you guys to be aware of and to know and to be confident about. So that is the end of today's lesson. If you have any questions over anything I talked about in this lesson, please feel free to email me. Otherwise, I hope you have a wonderful day.